Hello students, today we will discuss the next concept, that is a DIAC. So what is a DIAC? DIAC means it is also one type of thyristor which we are using, and it stands for diode for alternating current. This is one simple construction of again a number of layers and junctions, and this is also going to work like a previous all the different components what we have seen comes under the thyristor. And this is also similarity concepts it is having. And now the DIAC is a diode for alternating current, is nothing but it is working as a diode for AC supply. So how it is going to work for both the positive and negative half cycles of the AC, and what is the behavior of this DIAC we are going to see in this lecture. So now these are the two diagrams what I have shown. One is a DIAC construction. Here you can see the PNP. There are three layers which is looking like a transistor, also having the same structure. So PNP, and this side at the right side it is having a DIAC, but symbol it is. So now observe, it is looking like a structure of the transistor, but symbol if you are going to observe, it is a different. So it is not same as a transistor symbol, it is a different one. Here we are having the two diodes which are oppositely connected, and this type of the DIAC symbol is used for alternating current at the both the sides. It is going to allow the current to pass through it. And how it is going to allow the current pass through it? It is because both the diodes which are oppositely connecting, so they can give the chance, they are going to allow the current to pass through it. And PNP, the structure what you are observing here. So here by this we can say there is no how the impurities are going to be added in the transistor. In that fashion it is not going to be created. So the DIAC is a two terminal three layer bidirectional device. So we can have here only two terminals we are having, which can be this can be turned off or on from the either polarity is applied to the terminals. So it can be turned on and turn off from both the terminals. You can see at the top and at the below two terminals which are given to the P layer, and again at the below P layer. By using these two terminals we can turn on and turn off. The DIAC is very much similar to the transistor, how what I have said. And now all the layers here are having the same concentration, that is doping concentration is similarities. P layer, N layer and P, all doping concentration is having the same identical value. Sizes are also same. Now you can imagine, if consider the two terminals, I can take it as a anode 1 and another one as a anode 2. So you can give the name like this. So there is no anode cathode, and third one is a gate which is not there here. Only we have two terminals, and I am not mentioning it is as a anode and cathode. I am mentioning it is as a anode 1 and anode 2. So now using this I am going to apply a AC supply to this DIAC, and one load also I am going to connect. This is one simple imaginary circuit. When AC supply is given to the input of the circuit, then what happens? DIAC, whether it is going to conduct immediately or no. So this is one important task. When you are start giving the AC value, so it is having some voltage which is minimum voltage. It is required to break the junctions of the this DIAC. So for that minimum voltage we will give the name, that is called as a breakover voltage. So this breakover voltage is a voltage, minimum voltage, which we need to apply to make this DIAC turn on. And when the AC supply is given, so immediately it is not going to turn on. Initially the current slowly increases, and as soon as that given voltage is going to cross the breakover voltage, immediately your the DIAC is going to be turned on. So how this operation can be represented with the help of the graph. So that graph I am going to show you, that is a VI characteristics of this DIAC. So now by observing this VI characteristics, you can understand better that is how the DIAC is going to be conducted in both the directions, from anode 1 to anode 2, anode 2 to anode 1. So wherever you give the potential supply, either positive to the anode 1 and negative to the anode 2, or positive to the anode 2 and negative to the anode 1. So give any type of connection, but it will conduct from the both the sides. The graph is also indicating the same. So here in the first quadrant and in the third quadrant, we are having the curves. These curves are having the same structure like the SCR what you have seen in the previous class. So SCR is also having the same curves. In the forward bias condition, the SCR is going to conduct in the same fashion. So DIAC is also showing the same structure here, same diagram. So what is there in this diagram? So I am going to show you here in the first quadrant. That is indicating when you are going to apply the AC supply, obviously we are having the positive half cycle and negative half cycle. So in the positive half cycle, what is going to happen? So in the first quadrant, you are getting a curve which is indicating that curve is nothing but it is making the DIAC turn on. So initially you can observe here the current, what curve is there, V and I. So voltage, when you are going to increase slowly, the current is going to nearly equal to 0. It is not exactly equal to 0. So as soon as it reaches to here, we have mentioned break over voltage VB01. So when it reaches to this, so immediately the junctions are going to break and the DIAC is going to start conducting the heavy current. So nothing but DIAC is going to turn on. So as soon as the DIAC is going to turn on, your voltage is going to drop back. So voltage immediately comes down. So and current is going to be very heavily, it is going to conduct. So this is the conduction state of the positive half cycle. So now if you go to the third quadrant here, so here what happens? Again it is the same characteristics it is going to show. So what is happening? Again you are applying the same negative half cycle. So AC is alternating. Obviously it comes to the negative half cycle. The DIAC is going to allow the negative current also. So here also at some point, that is I am shown here VB02, that is a break over voltage 2. So as soon as the negative current also, it is going to reach VB02 break over voltage. So it reaches to that time, it is going to start conducting, and before that it is not going to conduct immediately. So this is how it is going to make the DIAC turn on. So break over voltage is a minimum voltage it requires to make the DIAC turn on from both the sides. So this is the working procedure of the DIAC. With the help of the VI characteristics, we can understand the concept of this. And next I will go to the next explanation, that is a TRIAC.